Okay, chapter 2.1, rational numbers. Now, rational numbers are a little different than integers. Our last chapter was about integers. And if we look at a number line, we have integers. Let's spell that right, maybe. Integers are all the numbers that we use to count with, the whole and the natural numbers, 1, 2, 3, and so forth, into infinity, as well as -1, -2, -3, and so far, so into infinity. But the rational numbers also include all the ones in between the numbers. So a rational number includes all the same numbers, but it also includes what's in between, like right here, 0.5. It would include things like right here, which could be 1.5, or it could be 3/2. It could be 6/4, other things like this, and the negative ones as well. So any number on the number line counts here. Any number that you can find on a number line using a fraction or a decimal or anything like that. Now, there are some numbers that don't work. Those are irrational numbers. Irrational numbers are things like pi or square root of 2, and there's several examples, and we can't figure out exactly what to do with those numbers, so they become irrational. The rational numbers all either have repeating decimals or a fraction that works. For instance, 1/3 ends up being the repeating decimal, 0.333, and that goes on and on and on. And you can use bar notation. This little bar over the top shows that it's repeating. So we talk about repeating decimals, which I think is one of the first things. Terminating decimals and repeating decimals. A terminating decimal has an end. It terminates, like 0.5, 0.75. Okay, so the fraction for 0.5 is 1/2, and the fraction for 0.75 is 3/4. So these are terminating. But repeating ones, like the one I just showed you, could be as easy as 0.66666, and it goes on forever and ever. The fraction for that is 2/3. Okay, and a lot of times on a calculator you'll see that they'll go 0.666 all the way to the end of the screen, and the last number they round up to a 7. Okay, so these are repeating decimals. Sometimes you'll find interesting repeating decimals, like it might do this. And it's just 125, 125, 125. And I don't know what the fraction is for that. But if it's really a pattern that repeats, you use bar notation like this. And the 125 is what repeats. So you can see that 125, 125 becomes 125 in bar notation. This one up here would become 0.6 in bar notation. And if you had some number that went 01, 01, 01, then it would be 01 in bar notation. That's just kind of how that works. And you want to be able to use bar notation. They give you a nice diagram, which is kind of cool. They show you whole numbers, integers, and rational numbers, and they show you examples of it on page 52. We could draw that, but I think I've explained it well enough, and you can look at it in your book. We'll get right on to examples. Example number 1 is writing rational numbers as decimals. So you take a number like -2 and 1/4, and you write it as a decimal. So you're going to rewrite it as a decimal. So we're going to change it to a decimal. And the first thing you want to do is rewrite it as an improper fraction. So 2 gets split up into fourths, and it becomes 8/4, plus that extra fourth becomes 9/4. It's still negative. And a fraction is just like a long division. This is like -9 divided by 4. And so we can just write our long division symbol, and we can say how many times does 4 go into 9. Now I'm going to remember that it's negative, but we're just going to do a regular division, and we're going to add a decimal and maybe a couple of zeros and just see what happens. Okay, so 4 goes into 9 twice. That's 8. 9 take away 8 is 1. Bring down your 0. Hopefully this is familiar to you. 4 goes into 10 twice. 2 times 4 is 8. 10 minus 8 is 2. And bring down a 0. And 4 goes into 20 5 times. 5 times 4 is 20, and there's nothing left, so that means that we didn't need this extra decimal. And our quotient is negative 2.25 because we started a negative fraction, so our answer is still negative. Because we didn't change this. This isn't really anything. We're just rewriting negative 2 1/4 as negative 9/4. Ooh, that looks silly. And then we're writing negative 9/4 as negative 2.25. These are all equal to each other. It's just a different way to write the same number. Okay, so we can use long division to help us rewrite a fraction as a decimal. Now let's take the second part of example 1. They ask us to figure out what 5/11ths is as a decimal. And it's the same thing. We remember that 5/11ths is 5 divided by 11, which means that we get a fraction bar out. And we say, how many times does 11 go into 5? And some of you recognize that it doesn't go in once. 5 is smaller than 11. And we see that here, this is close to 1/2. Right? If it were 5/10ths, it would be 1/2. Or if it were 6/12ths, it would be 1/2. We happen to have 5/11ths. So this is close to 1/2. And when we write it, our division sign like this, we definitely need our zeros. I don't know how many we'll need. We'll just find out. 11 goes into 5 0 times. And we have our decimal here. So now we kind of ignore this one and we think 11 goes into 50. Well, 11 times 4 is 44, so that works. We subtract and we get 6. Bring down our 0. Looks like 60. So 11 times 5 is 55. And then we have 5 left over. And bring down our 0. And now 11 goes into 50 5 times. Ooh, it doesn't go in 5 times, that'd be 55. It goes in 4 times. 4 times 11 is 44. And we're back to 60. And I'm starting to see a pattern. I've got 50, 44, 60, 55, 50, 44, 60. And so I'm going to go 4, 5, 4, and I could bet that my next one is going to be a 5, and 5 times 11 is 55, and I'm going to go back down to 60, and 40, 50. Ooh, boy, silly Mr. Armstrong. And then we'll have to drop down to 4. So it's 4, 5, 4, 5, and it's just going to keep going. But we have to rewrite this answer then as a bar notation. We can't just write it forever, and we don't want to write it a whole bunch of times and then say ... So we're going to rewrite it in bar notation, which is 0.45 with a bar over the part that repeats. You only put the bar over the part that repeats. Okay? Quick and easy. Now we're going to go the other direction. We're going to write a decimal as a fraction. Okay, so example 2 is changing a decimal into a fraction. And in some ways this is still easier. This is something we kind of did with that little quiz that we took earlier. And they give us a decimal 0.26. Okay, so this is the same thing as negative. And then we kind of cover up this negative sign. We think this is 0, and sometimes we say it's just 0.26, but there's a correct way to say it. 0 and 26 hundredths. Hopefully you remember that. So we have negative 26 hundredths. That's a fraction. And, well, we're not actually done. We're almost done. Now we just have to simplify it. I can divide 26 and 100 by 2. So I'm going to divide both the top and the bottom by 2, effectively dividing by 1. And I get 13 50ths. And when I look at that, that is as simple as it can get. I can't divide by 13. Well, I can divide 13 by 13, but I can't divide 50 by 13. So this is a good stopping point. This is simple. You always want to simplify. And this is the simple version of 26 hundredths. Oh, and I don't want to forget my negative sign. This is something that happens a lot. we just work on this problem. We forget that negative that's hanging out there. We got to keep that in the problem because that's going to be part of our answer. Okay, that should pretty much set you up. The only other thing is when you have to order it. So they give you an example where you have to order a bunch of numbers. So they say write it as a decimal and then put it in order. So you have negative 13 tenths, you have negative 2 1/5, and you have negative 2 elevenths. And you have to change it into a decimal, and then you have to put it in order. So this is, when it's tenths like this, there's a little shortcut. 13 tenths looks like 10 tenths would be 1, right? So 13 tenths would be 1.3. And I could do that with long division, or I could just write 1.3. Now, the long division would be 10 into 13. And 10 goes into 13 once. You get 3, bring down the 0, and 10 goes into 33 times. And 3 times 10 is 30, and you have 0 left over, so we're done, 1.3. And it's still negative, so let's remember that. So there's kind of a trick there. I could actually change this to negative 2 2/10, because 2/10 is the same as 1/5, and do the same thing. So I'd have negative 2.2, because this is 2 2/10. 2 1/5 is 2/10. So there's kind of a shortcutty trick for you. And here we actually have to do long division. We don't know what 2 elevenths is. That's 11 into 2, and it's really negative, but we'll save that. We'll save negative for our answer. We just have to remember to put it in up here. 11 goes into 2 0 times, but it goes into 20 once. 1 times 11 is 11. 20 minus 11 is 9. Bring down the 0. 11 goes into 98, which is 88 times. 90 take away 88 is 2. Add another 0. Bring it down. We've hit 20. Oh, we're back to where we started. So 11 goes into 20 once, which is 18. Subtract, you get, it's not 18, it's 11. Come on there, let's have some math. Thank you for paying attention. I'm glad you caught me. 20 take away 11 is 9, but that's what we had up here. Bring down as another 0. We have 90 again. You can see that we have a pattern that's repeating. So this is equal to negative 0.18 with a bar over it. Once we get these three numbers, then we can put them in order on a number line. And let's change the color for our number line. And we have negative 1.3, negative 2.2, and so we have kind of a 0 here. Maybe there's a 1 over here, and a negative 1, and a negative 2, and that goes forever in every direction. Okay, so this one is about right here. That's negative 2.2. That's this one. Okay, negative 2.2. And negative 1.3 is you start at 0, you go negative 1. 1.3 is about here. And this one over here is negative 0.18 is negative 0, and it's just a little bit left of 0. And that's our point there for that one. And that's how you put it in order. So that was a little more work. Have fun with this assignment. Talk to you later.